Good afternoon. This will be a shorter video, just going through a few of these questions. I'm happy to share the answers to these with you the next time we're together, but I'll just do a few of these right now. So we'll start off with 1f. When I take the derivative of this thing, this is going to be both just a straight old power rule, so the derivative of 3x is just 3. And then when I have the x times the tangent of x, I have to use the product rule. So I'll write it all out. It's going to be the derivative of the first times the second plus the first times the derivative of the second. Now, you do not need to know the derivative of tangent yet, but it's not a tricky derivative to use anyway. It's just secant squared. So this is just 3 plus the tangent of x plus x times secant squared of x. Notice the derivative of x is just 1. And this is how I'm going to leave this. Again, we talked about this last class, but I'm not going to try to go any farther with my simplification. That's where I would leave it. For the equation of a tangent line, equation of a line tangent, I'm going to get a point, and I need to get the slope. So let's first go ahead and get our slope. To get the slope, we're going to take the derivative. So the derivative of sine is cosine, and the derivative of 3 is just a constant, so the derivative is nothing. So we're going to take the derivative at pi, so cosine of pi. Cosine of pi is -1, so that's our slope. And now we need to also get a point. So for the point, we go back to our original. We're going to do the sine of pi, so we're looking for the sine, y of pi, which is the sine of pi plus 3. The sine of pi is just 0, so our point is pi comma 3. So our point here is pi comma 3. We have a slope of -1. We can write this very easily, whichever form you like. Point slope, slope intercept, I don't care. But definitely point slope is easier there. Number 3, again, this is a function times a function, x squared times the cosine of x. So we're going to have to use the product rule. We're finding the equation of a tangent line. So we find the equation of a tangent line. Again, we need the point and the slope. We're going to take the derivative. So y prime is equal to the derivative of the first, which is 2x, times the second, which is the cosine of x, plus the first, which is x squared, times the derivative of the second, which is negative sine of x. So I'll rewrite this just a little bit. This is 2x cos x minus x squared sine x. We need two things. We need the point and we need a slope. So our point here is going to be 9. So I need y of 3, I should say. It's going to be 3 squared, or 9, times the cosine of 3. So our point is 3 comma 9 cos 3. Ugly. Then we're going to take the slope. Our slope's going to be even uglier. Our slope is going to be y prime of 3, which is going to be 6 cos 3 minus 9 sine 3. Now this problem you could use a calculator on. I don't have one at my disposal right now, so I'm not going to do that. But obviously you could simplify this using a calculator. Remember, when we use a calculator on this, we're going to get out to 3 decimal places. All right, now 4b. 4b, cosecant is 1 over the sine, and we're going to take the derivative. We're using this information that the derivative of sine is equal to cosine in order to prove that the derivative of cosecant is negative cosecant cotan. So we're going to use the quotient rule here. It's going to be the bottom times the derivative of the top, which is 0, minus the top, times the derivative of the bottom, which is cos, all over the bottom squared. Now, we just found an expression that represents, that's supposed to be squared, I'm sorry. We just found an expression that represents the derivative, but we don't like to memorize it in that form. This is really just us being, I guess you could say, we just like it in a different form. As math people, we like to deal with this in a different form. This is the same as -1 over the sine of x times the cosine of x over the sine of x. -1 over the sine of x is the same as negative cosecant of x. Cosine of x over sine of x is cotangent of x. Generally speaking, I've actually never seen a textbook where this is not given to you as the form in which it should be memorized, but it would be just as valid if everyone in the world decided it would be cosine of x over sine squared of x. That would be totally fine. All right, number 5, show that they both have horizontal tangents at x equals 0. Well, we know that the derivative, or maybe you don't, but that you can look it up, the derivative of secant is secant of x tangent of x, and the derivative of cosine is negative sine of x. And all we're checking that the slopes of the tangent lines are equal to 0, so at x equals 0. So I'm going to do the secant of 0 times the tangent of 0, which will give me 0. And then I'm also going to take a look at negative sine of 0, which is also just equal to 0. So I just showed that those two graphs have horizontal tangents at x equals 0. Number 6, equations for the lines that are tangent and normal. So tangent's going to take the derivative and plug in. Normal is going to be the negative reciprocal. So let's do the tangent first. So, well, actually, let's get a point first. Let's get a point. So our point, it tells us it's pi over 4, comma 1. So let's get the tangent. We're going to take the derivative. Our derivative here is going to be negative root 2, all right, times the sine of x. Remember, whenever we have a constant out in front, we can just rewrite it. If you want to use the product rule, by all means, go ahead, but you're kind of just spending some time you don't need to. This y prime of pi over 4 is going to give me the slope of the tangent line. The sine of pi over 4 is just root 2 over 2. So this is negative root 2 times negative root 2 over 2. And that's just going to give me an answer of negative 2 over 2, or just negative 1. All right, so that's my slope by tangent line is negative 1. And that means the slope of the normal line is going to be the negative reciprocal. So the negative reciprocal of negative 1 is just 1. And now it's just a matter of writing our equations here. This is going to be y minus 1 equals negative 1 times x minus pi over 4. And my other one's going to be y minus 1 equals 1 times x minus pi over 4. Thank you and good night. Find an equation for the tangent to the curve y equals 4 plus cotan x minus 2 cosecant x at x equals pi over 2. So this is, again, all we're going to do here is take the derivative of that y, and then we're just going to find a point. All right, so let's go ahead and do this one. This one's a bit of a pain. I'm going to do this one, and let's try gray. Let's see how that works out. See if you can read it. So first thing, let's get the point. So let's do y of pi over 2. So this is for the point. I want the point. So I'm going to do y of pi over 2 to figure out my y coordinate when x is equal to pi over 2. So it's going to be 4 plus, I'm going to write cotan as cosine of pi over 2 divided by the sine of pi over 2. Cotan is cosine over sine. Then I'm going to write cosecant as 1 over the sine of pi over 2. So this cosine of pi over 2 over sine of pi over 2 is just going to yield 0. And the sine of pi over 2 is just 1. So that whole piece is just 2. So this, my point here is the point pi over 2, comma 2. And then what else do I need? I need my slope. So to get my slope, I'm going to take the derivative. Take the derivative. The derivative of cotan is negative cosecant squared x. And the derivative of cosecant is negative cosecant cotan. So this is going to become plus 2 cosecant cotan. Those only need to be memorized after this next test. You don't have to know those for this test. I won't put anything on there. Plugging this in is ugly, but not difficult. It's going to be, this is the same as negative 1 over the sine of pi over 2, that's cosecant, squared, plus 2 times 1 over the sine of pi over 2, times the cosine of pi over 2, divided by the sine of pi over 2. Wow! All right, so then here we go. This whole thing, this piece over here, this whole kit and caboodle, that just goes to 0. So that means this whole thing goes to 0. So I can ignore that. That all goes to 0. The negative 1 over the sine of pi over 2 squared. The sine of pi over 2 is 1. 1 squared is 1. So the slope here is negative 1. Y prime at pi over 2 is just negative 1. So now I have my slope, I have my point, and I can write my equation for my tangent line. It's negative y minus 2 times negative 1 times x minus pi over 2. Carry on. Have a good day.